Well, hello, everyone, and welcome to today's panel discussion entitled Ground It Right, Reduce Static Disasters and Hazmat Transfer. I'm Greg Wong with AEMC Instruments, and I'll be serving as the moderator for today's session. Handling and transferring hazardous chemicals are inherently dangerous work. Beyond the obvious risk of spills and leaks, there's also a hidden threat that can be just as catastrophic: static electricity. A single spark has the potential to ignite vapors in a hazardous environment, turning a manageable situation into a major incident. That's why today's conversation is so very important. Our panel of experts will guide us through a discussion on the reasons why, the processes, and safety practices for reducing static-related risk during material transfer. Together, we'll cover why proper bonding and grounding is so critical, how to identify susceptible areas in the field that may need grounded and bonded, and the best ways to protect both responders and the public. We're going to structure today's conversation with a blend of live panel questions, interactive polls, and a question and answer at the end. We'd encourage you to participate by sending in your questions in the webinar chat located up in the top portion of your Teams browser. If we're unable to answer your questions by the end of the webinar today, we'll reach out within a week's time with an answer. By the end of this hour, it's our hope that you'll walk away with a clear understanding of the standards, tools, and strategies you can ensure to ensure safe hazmat transfer operations. So let's get started with introducing our panelist. Michael is here from Safe Transportation Training Specialist. Michael Moore, would you like to introduce yourself a little bit better?
Thank you very much. I look forward to participating. One of the things about my background is it's blended. I've been a volunteer firefighter since Boy Scouts, and that has allowed me to understand the emergency services side of it as I participated in different levels of firefighting and in county hazmat, CERT, and other things. But being a volunteer also required that I had to have a job. And the job that I had was with chemical Lehman tank lines. I started out as a mechanic for chemical Lehman tank lines, went into being a tank cleaner, and then a waste treatment plant operator, and then eventually joining the safety department and helping to manage and run our 80-man industrial hazmat team for chemical Lehman tank lines. And then Safe Transportation was born out of that. And now we focus our training on highway transportation issues, but also are able to use and speak with firefighter vocabulary.
Great. And Safe Transportation Specialist is one of our valued distributors for the AEMC Static Grounding and Bonding Kit, which we'll discuss later on. I'll introduce myself again. My name is Greg Wong with AEMC Instruments. I'm the product manager and technical trainer. I support this product line as well as others for AEMC Instruments. I'll be helping answer all questions related to grounding and bonding from a practice of installing and completing testing for the use of static grounding and bonding materials for scene cleanup. Keith Silverman is with us from TRANSCAER. Keith, would you like to introduce yourself?
Sure, Greg. Like Mike, I started out as a firefighter and hazmat technician, got a little bit nerdy with hazardous materials, so spent some time going back to school, learning a lot more about hazardous materials, and spent my career in the chemical industry. And recently retired from there, so spending my time doing some consulting, training for TRANSCAER, and I'm also an instructor at the Somerset County, New Jersey Emergency Services Training Academy. So I like to spend time training responders.
Great. And we really appreciate both Keith and Mike's participation in today's webinar. Keith mentioned TRANSCAER, and TRANSCAER is a new organization or an organization that AEMC has recently joined. Keith, would you like to share a little bit more about TRANSCAER and how it may benefit those who are in attendance today?
Yeah, sure. So, TRANSCAER has actually been around for almost 40 years, Greg, and it's a national outreach program that really works to get people in the industry and people who ship chemicals. So as Mike was saying, folks who ship it over the road, folks at the railroad, the folks who make the chemicals like myself, and prepare communities and emergency responders in case a spill or release happens in their community, help take that anxiety out of the picture, help with awareness, and then help them just to respond more safely and more efficiently when there's a call. So it's folks like Mike, it's folks like myself, it's folks on the railroad, and they volunteer their time through their jobs, and they go out and they train responders throughout the United States, Canada, and even Mexico. And if you go to TRANSCAER.com, the website, there's a ton of stuff available online. We have a learning management system. All of it is free training for responders, I should say. It's all free training. So it's an LMS system that's out there. We have some different funds, like a Hazmat response team fund, where we give some grants out on an annual basis. Next one will be early 2026. We have this Seconds Count video series where we do short videos. We just taped a bunch of them at the Fire Academy a couple weeks ago, and those help instructors and trainers, officers train their staff in a short amount of time. So it's a bit of information put together in a short format that you can use. We also have a podcast, Hazmat Files podcast, and just a bunch of other stuff on the website. So check it out.
Great. We'll definitely be sure to take a look at the LMS. It's available 24/7 at hazmatcourses.com. I've accessed that recently. It's a wonderful resource and a ton of free material. So thanks, Keith, for sharing that. Let's go ahead and get started with today's panel discussion. And we'll start actually by engaging you, the audience, with a poll question here. So before I jump into that, though, let me briefly cover AEMC's static grounding and bonding system kit here. This is an all-in-one kit designed to provide everything needed to safely deploy and test grounding and bonding systems used for static control during material transfer. So these are temporary systems that this kit can deploy effectively, and as well as provide the testing to ensure that the connections are made well. This complies with NFPA recommendations and includes all the essentials from the meter and leads, grounding rods, bonding cables, and a driver extractor tool. It's all housed in a rugged waterproof case. With this kit, responders can confidently respond to and complete using a ready-to-use solution to reduce the risk of static discharge in a hazardous environment. If you want more information on our kit, feel free to reach out to us on the contact information below or check out AEMC.com. All right, now we'll move on here to our panel discussion. We'll start with that poll question here too. So in a second, you'll see a poll question pop up. You can answer that poll question. And if you choose to answer the poll question too, we're going to be giving away a few useful test instruments to one participant who answers a poll question. So let's get started with question number 1 here. Have you or your organization ever experienced a safety-related incident that related to static electricity, there we go, during a hazmat cleanup operation? Also, too, if you cannot see the poll question, please check the chat function. Those of you joining through a browser may see this question pop up there. If you still can't find the poll question, please drop the answer into the chat and we'll be sure to record it here. So have you or your organization ever experienced a safety incident related to static electricity during a hazmat cleanup operation here? And it looks like the majority of individuals are answering no to this question here. Some are answering not sure. So those of you that have, you may be able to share some of your experiences in the chat as well too, or ask either way you have or haven't, please ask some questions in the chat if they come up during the conversation here. So let's get started with our panel questions. First question is going to go to Mike here, and that is, as first responders on an emergency, such as a spill or a leak, how can we safely and quickly determine susceptible areas for static grounding and bonding, and what necessary actions do we need to take?
Well, on first arrival, you need to check with what you see as you pull up. We would normally in a fire service do a quick size up, but in a hazmat situation, we have to learn to put the brakes on and slow down and really realize what are my wind directions? What's my topography? What direction am I approaching from? What are the people on the scene doing and telling as I pull up? Is the driver or train crew available to give any information? So you want to know what's going on first with the people, and then when you look at the piece of equipment that's involved in the crash, does it have obvious dents, scores, or gouges, or other signs of damage? And then really start moving in a little bit slower. But if this has got placards or any other kind of indicator that you're dealing with a flammable liquid, then you have to be a little bit more concerned about doing air monitoring and making sure that you've eliminated any ignition sources. And then whenever you get ready to start your transfers, get set up, you want to have your grounding system set up uphill and upwind away from the potential work area so that you can eliminate trip hazards.
Great. So as a follow-up for you, Keith, in terms of static electricity, when we discuss when we need to deploy these systems, what type of chemicals are we most concerned about during the transfer operation?
It's a good question, Greg. So, let's think about what Mike said too, or let me add on to what Mike said before I answer that. The other couple of things to look for when you get there, look at signage, like especially in an industrial setting. If we're unloading or loading tankers, areas like that, you'll see no cell phone signs. You'll see those electrically classified equipment. We often call it explosion proof or intrinsically safe. You'll see the big lights that'll look like intrinsically safe. So those are all other clues that we could be dealing with that. And I think that leads into then, what classes or what things. So, if you think about it, there's your traditional flammable liquids, right? So your class 3s, they're going to be there, as well as combustibles. I would also think about class 2, where we're talking about flammable gases, and even some gases that are not placarded flammable or labeled flammable gases could be flammable. So any type of gas or vapor, I'd be thinking about it. Then we get into solids, flammable solids, obviously class 4, but there's also some solids like dusts where I would be worried about static. So I'm always worried with finely divided powders or dusts, but in those solids. Also class 5-2, your organic peroxides, you'll be looking out for it there. And class 8, a lot of corrosives can also have some flammability or be flammable. So those would be the major classes of chemicals I'd be looking for.
So really, we could summarize it: if we're uncertain, we don't know what type of chemical is possibly being transferred, we also have to be considerate that there could be some type of contaminants being introduced as well, too. It's probably a safe bet to go ahead and perform the process of static grounding and bonding. That'd be a good assumption, Keith?
Yeah, absolutely. I mean, you raise a great point there, right? Anhydrous ammonia is a perfect example of that. As it gets contaminated with oil or other things, it changes the flammability range. It may even change the LEL. So you always have to be thinking you're not dealing with a pure chemical. So static is unpredictable, and I would take the safer or have more precaution and be safer and be prepared to do it.
Great. Well, let's move on to our next poll question. So this will be launched for the audience to answer. Do you already have a formal static grounding and bonding policy in protocol in place for hazmat cleanup procedures? Yes, no, or not sure. We'll wait for that to load there. It should be up for those of you in the audience. Again, check the chat to answer that. It looks like the majority of the audience does have a policy, although more answers are coming in here. It's kind of eroding that yes. So we're seeing about 50% of you do, 50% of you don't. If you don't, we're going to discuss some opportunities for materials that you may be able to gain from TRANSCAER or other resources later on in the presentation today. So if you're looking to amend yours or create a new process, be sure to check in for those resources later towards the end of the presentation today. All right, moving on for our next panel question. This is going to go to Keith first, and then we'll let Mike follow up on it. Which are the risks, or what are the risks associated with static electricity, and what are the susceptible areas for static generation release at an accident site?
Okay. The thing with static, when I think about static, is look, it's really variable. It's hard to conceptualize it. You can't see it. It's hard to know when it's going to happen, right? So it's just very unpredictable. And you hinted on that before when we were talking in the first question. It's really unpredictable. And if you think about a spark, a colleague walks across the floor, drags their feet, touches somebody, and the spark discharges. You can hear that, you can feel that. But when we're in the field doing transfers or in an industrial setting, the spark can be so small, way below any level that could be perceived by a responder or an engineer. And that small spark or that small discharge can have consequences. So it's that unpredictable nature of not being able to see it, not knowing when it's going to occur, that I think, is the riskiest part of it. And, the second part, you asked a little bit about materials, right? Or different types of situations where it occurs. And I've seen it occur in cases where liquid's flowing through a hose. I think that's probably the most common one. People have all seen fires as a flammable liquid gravity feeds through a hose. But you can find it from liquid sloshing around in a tank, powders and dust coming out of a hopper or a super sack type container can generate the charge. I've seen it with aerosols moving through actual flammable vapor. So I've seen a tank explosion occur once as a aerosol was moving through a flammable vapor, and it generated enough, as because the static comes from when two materials move against each other and you get that friction and they become charged, and the aerosols moving through the vapor were enough to do that. So that was really unique one. And metal on the ground, we talk about accidents, right? Metal pieces on the ground, responders may trip on them, step on them, kick them, they'll move against the ground. You might generate one. Any type of plastic, things like that moving across metal. So just tons of examples, and probably not ones you would always think about. It's tough to size it up sometimes.
Right. Yeah. And I think really that's what's important to realize here is there's so many overlooked sources of potential static charge creation and discharge that by properly grounding and bonding all the time, and everything that we can ground and bond at a scene is ideal to create the safest scenario. One area I wanted to highlight is, Keith spoke a lot about where static can be created, but even arriving at a scene, static charge may already be stored in the material, especially petrochemicals, like viscous oils they're more insulative in their resistivities and therefore can store a charge on their surface very easily. So while we may be concerned specifically with creating a static charge, therefore leading to discharge, it's important to realize that a charge may already have been created and stored at the scene when we arrive. So let's move on to, thank you very much, Keith, for that answer. Let's move on to our next poll question here, and we'll let Mike tackle this one here. Which components at a scene must be correctly grounded and bonded, and then also tested prior to the transfer of flammable materials to ensure no hazardous material transfer ends in tragedy here? So Mike, when you get to a scene, can you walk us through the process of what needs to be grounded and bonded?
Certainly. The first thing you want to do is, once you've identified a need for the grounding source, a place to allow this electricity to go to Earth, you need to establish the ground area, test it, set out your test runners so that you know that your grounding rods or rod is sufficient. And then you want to connect to your damaged vessel first, your damaged rail car, or your damaged cargo tank, and then come back to the source of the ground rod and make your connection there. So damaged vehicle first, and then to the grounding system. And air monitoring this whole time is also key, so that you know that the static electricity, whenever you were talking about the ability of a vehicle to have capacitance or store electricity, as that truck or train is going down the road or down the track, just the simple air movement over the outside of the vehicle is going to generate static charge on the vehicle. Not to mention the liquid sloshing inside generating static. So again, the proper sequence would be establish a ground rod system, test it, connect to your damaged vehicle or cargo tank, and then to the ground rod. Once your recovery tank shows up, or your contractors show up to do transfers, then you want to connect to your recovery tank first, or no, sorry, connect to your damaged tank first, and then over to your recovery tank. And because your recovery tank should be in a relatively safe area. So establish a ground system, test your ground rods, connect to the damaged vehicle or cargo tank, and then to the ground system. And then whenever the recovery system shows up, connect to the damaged vehicle first, and then bond over to your recovery tank. If you're moving flammables, I would also recommend that you bond your transfer pump as well to make sure that it's a part of the system. And all of these connections need to be outside of the normal work area. So if you have center valves or rear unloading valves and you're making a transfer, consider making your grounding and bonding connections up on the nose of the truck so that no one is working or walking around your ground cables. Those are key things.
Yeah, thanks for that, Mike. You know, I've in doing the training for our kit, going to come up with a saying to simplify the process here, and that's ground, test, bond, test. So when we perform the grounding aspect, we're driving a ground rod into the ground, or some other type of forming some other type of electrode. It could be horizontal or vertically laid into the ground. We need to test it, and the purpose of this test here is to quantify the quality. So it's a resistance test, specialized resistance test, also often referred to as the follow potential method. And if you look at our kit or look at our training aspects for our kit, you'll see that there are other types of test methods available to you for that, but that's usually the principal test that we utilize, called follow potential, to quantify the quality of a connection to the ground. Surface area is king here. So the longer the rod, the more rods we can install into the ground, the better of a connection we will establish to the earth itself. So that's the ground piece. We're going to test it. Then we're going to bond, and we need another test called continuity or point to point to qualify the quantity of the quality of the connection, rather, for our bonding as well too. So a question came in I thought I would tackle real quick is, does the pump need to be grounded or bonded? And Mike, I think you nailed the answer there. Is but what kind of clamps do we need to utilize? Because we've got to bond that pump. And I made here a slide just to follow up on some of the materials that you'll find in a good static grounding and bonding kit, the difference of the clamps here. So Mike, any comment on these clamps? Have you utilized these in the past? I know you'll find one of these in our kit.
Yes, I personally like the pinpoint clamp because if there's any debris or paint or anything, you want to try and go someplace where it's not painted. But this pinpoint allows you to grip into the surface. Plus, it's going to hold itself there. The aircraft style grounding clamp, you typically would see those more like if you're going to be connecting into a predetermined ground point or a copper monkey fist in industry, where you're going to be clamping right to a ground. But if you're making at an accident scene, a crash scene, you're making this connection, you want to connect, and I believe with the pinpoint type clamp, and you want to avoid the bottom of the vehicle. One of the things about the bottom of the vehicle is it's usually painted with a durable undercoating, and so it's going to be hard to get a bond or a contact. So go directly to the barrel of the tank or anything welded to the barrel of the tank, or on top of the tank so you have shiny spots or clean paint-free surfaces.
Yeah, I think it's interesting. The more testing I've done on bonding systems, the more we actually see them in too high of a resistance based on NFPA 77 guidelines. And these are primarily due just to the contaminants or paint or coatings that are seen on various different vessels or chassis, cross members and so on. So look for something welded. First off, ideally, you'll find a ground point that is accessible, labeled usually with the grounding symbol. But if that's not available to you or it's not in a good working area, consider something that's not bolted on, that's a frame member or a part of the vessel that is not or has little contaminant, and use the proper clamp. I think it's important that you also highlighted these have a very high mechanical tension to them as well too. So they're going to stay on and be able to withstand some tension being applied to the actual bonding lead. So thanks, Mike, for that answer. I think that's a great way to move into our next question here.
Greg, can I add one thing to that?
Please
Sorry,
do, Keith.
So I agree on the pinpoint clamps. I think they work the best. The other thing is if this happens in a fixed facility, right? Always set up your own grounding and bonding system as well. And you like that redundancy. And you oftentimes can, in a system like that, in a fixed facility, if you look at the piping, you'll see piping carrying flammables. It'll be welded and it'll have those jumpers, those bonding jumpers from between the flanges so that you get that good, conductivity between it, low resistance. But I always think it makes sense too in a situation like that to set up your own system. Maybe you use their ground, but check it. And always get that test in there to ensure you have that low resistance.
Yep. Great. Thanks, Keith. Being able to perform the tests is one of those key critical pieces that seems to be missing out of a lot of processes for static grounding and bonding. So you look to AEMC for good instruments there, but even if you're not using an AEMC instrument, you have a question on how to perform this process, reach out to TRANSCAER or AEMC. We're happy to help there. So on to the poll question here for the audience. It's the last poll question. Feel free to jump in here and answer this either in the chat or on the poll that should be popped up on your screen here. In your opinion, what's the most critical factor for a successful hazmat cleanup operation involving static grounding? Is it proper training, reliable equipment, strict compliance, or effective communication? And this is, you can answer all or none of the answers above here. So feel free to check as many boxes as you think are applicable here. And, Keith, I think I'll jump in and have you throw your opinion in here on this one. I think specifically strict compliance. Now, we have some standards that we'll discuss later on, but in the process of static grounding and bonding and dealing with just the various scenarios, how do we overcome the need, the lack of information to deal with every specific variable that could be at play here? Do you think really just having strict compliance is super important, or should we more rely on good equipment and proper training here for this question?
I think it's a little both. So let me start with training, right? I think everything starts with good, solid training, but training is not the answer to everything. You need that hands-on and that practice, right? That muscle memory, so you do it all the time. But when you're talking about training, right, you got to look at where static can be a variable. And you've heard Mike talk about that. I talked about that. You talked about it a bit. It's unpredictable. So you really need that hazard recognition about where can static be the variable. Look for clues, placards, labels, signage, bonding jumpers, welded piping, all the things we've been talking about. They're all clues. And then, once you do that, then assess the scene for those static buildups or potential static buildups, all those areas around there. And then I think part two, as you go to it, then it becomes to practice it, right? So you also have to think, wear your PPE, your full PPE, because you don't want to be the source of static. So wear your PPE, and if something flashes, you want protection. So take all those steps, right? Wear your good PPE, use direct reading instruments, as Mike was talking about, but take your time to set the grounding and bonding up. Take your time to do the testing. And even though you may not need it, it's good practice for when you do need it. And you're more confident with doing it. You're more confident with the results. And you'll run across things sometimes that make you scratch your head. I'd rather get them out of the way when I didn't need it, or maybe I was just being cautious, following procedure. And then at least I have a good, solid understanding of it when it really matters. So I think it's training and practice.
Great. Great. So for the next panel question, Mike, you've sort of already touched on much of the answer to this one, so we can revisit that quickly here. But I think it'd be helpful to point out maybe some uncommon areas where grounding and bonding may need to be utilized. Maybe you have some practical experience here. So, like on a scene, what does need to be grounded and bonding specifically? And like I said, you could rehash what we already discussed. But verifying it through testing, like what's the importance there prior to starting a transfer? And then again, if you can add any experience to maybe some areas where we don't typically think of utilizing grounding and bonding for various things found on a scene, like maybe inside of a hot zone.
Well, anytime that you're going to be moving a flammable liquid, even a free fall of a flammable liquid through atmosphere, can generate static and cause itself to catch on fire. So it's key to bond both the damaged vehicle or vessel to the receiving container, whether it's a bucket, a 55-gallon drum, or a tote, whatever you're moving that flammable liquid into, it needs to be bonded together. For me, static electricity, I first realized that I was in a static electricity issue, moving dry powders, dry flowables at nighttime on a railroad siding, using a stainless steel wrapped hose to blow these powders through. I had no idea that as this hose was connected to the bottom of the rail car, when it laid against the railroad track, there was that blue arc taking place, and I was in a transfer situation, and it was powders. But you don't think about the particulate, like Keith mentioned earlier. The other thing that happens with grounding and bonding for me in real life is you don't know what you don't know.
Sure.
And that's the thing. Once I found out how to sufficiently verify that my ground source was adequate, then I became more confident okay, look, I know that's a reliable ground source, whether it's the 3 ground rods bonded together to give me more surface area, or a guardrail post or a sign post. And you still have to test those items. But then you just need to make sure that, okay, now I know that static electricity is here. How am I going to minimize it? And that comes through bonding your equipment into the system whenever you're using it. But I was really amazed at what I didn't know.
Sure.
And then once I started getting into it, I thought, oh, yes. Oh, okay. And then it's a use it or lose it type situation too. Just as Keith said, you have to practice with the test kits that you have, with all of the different things you have to have. Take it out of the box, use it, practice with it. Right. And you get, because during that practice, you're going to go, oh, well, that didn't work. What did I do wrong?
Right.
And then you're going to go, oh, yeah, okay. I didn't make the wire nut didn't make a good connection on the rod, or the clamp didn't, the pinpoint clamp didn't actually grip the rod. It gripped around it instead. So practice is really what you have to do.
Yeah, so let me address what the need for grounding and bonding are specifically. So grounding here is establishing a connection to the earth. And the earth itself is so massive and large, we can't appreciably raise its voltage. So we'll call it 0 volts. And when we bond things together, we establish an equipotential connection, or potential being another word. We could throw voltage in there. So we could say an equal voltage. And if we reduce the voltage or equalize it, we no longer have the potential for current to create a spark, right? Because everything is at the same potential. They're equal voltage. So by bonding everything together, we're minimizing voltages, and then we're creating a connection to the earth, which is at 0 volts. Therefore, everything should be at a very close or 0 volt reference point to each other. So we're minimizing voltages and allowing any creative or created charge a pathway to the earth. So Keith, we haven't heard from you, and I'm interested to see if you could walk us through what your order of operation is here for grounding and bonding when you're leading training.
You mean technically how to do it as Mike described, or you mean more of what we're going to focus on?
Like give us kind of a holistic approach here to,
Okay.
If you were going to just explain the process of grounding and bonding in a quick 30 seconds or a minute or so, how would you describe the process from a technical perspective?
Yeah, so I mean, I think about it as we talked about earlier, right? Anytime there's two different materials moving against each other, there's the potential for static. So that brings in a lot of things when I don't have a lot of information, right? And then once I have that charge is going to build up on the surface of both materials. And then at some point, that charge is going to increase the voltage of that material. So how do I dissipate that charge, right? So that there's not that big potential difference between the two. And that's where bonding and grounding comes in, right? So bonding is just taking that charge and evening it out between everything. Grounding is actually sending the charge to the earth so that it dissipates.
Great. So a few things on charge too, since we're on that subject. It's important to realize that with static specifically, we're dealing with a lot of voltage, and we could think of voltage as a source of pressure, right? So if you use the water analogy and you had a vessel of water connected to a hose, we would say that between the ambient air and that hose, there is a potential or a pressure. Similar here with static electricity. If we think of current, in an electrical system, current is going to be the rate at which that charge is passing by a specific point. So I like to use the analogy here for static of water through your spigot on the hose side of your house there, or maybe at a faucet, versus squirting water out of a spray bottle. And that would be more like static electricity versus what's coming out of your faucet. It'd be more like electricity you'd find in your home, right? So it's a lot of water, but at a fairly moderate pressure, versus what's coming out of a spray bottle, very little amount of water, but a lot of pressure propelling that water out. So here we're not dealing with a lot of actual electrical energy. The energy content's pretty minimal, but we're dealing with a lot of pressure, and that's what's causing that spark to occur. It's important to realize that static can occur as low as 30 volts. A static discharge, very minimal discharge, but can occur as low as 30 volts. We typically don't see it until we approach the 8,000 volt range, but it can well exceed 100,000 volts in some instances. So very large variance there between the amount of pressure that can create static discharge and could be a sufficient source of energy for an ignition. So again, gets back to the whole thing with static of being a variable that's really hard to control here. So let's jump on. Thank you both for those answers. I think it's very helpful to give a background, just grounding, bonding, and just a very brief on static too. So Keith, you're up for this one. And I think this one's super important for you to cover with your TRANSCAER background. What can we do not only on the scene, but before we get there, before we even respond to something, to provide a safer work environment for responders handling products? And I'd love to hear more input on like actual other equipment other than just the static grounding stuff here? What other stuff should we be prepared to show up with to one of these scenes?
Yeah, sure. So, we talked a little bit about some type of direct reading air instruments to detect the flammable vapors. So multi-gas meters, photoionization detector, things like that. But they won't get everything. And we've been talking a bit about dusts as well and powders. And very similar to your analogy on mists, those powders are going to be just fine, almost like droplets moving through the air. So what is your equipment rated to? And I think sometimes we're not sure what our equipment is rated to. And if you look at NFPA 70, the National Electrical Code, right, it talks about equipment used in hazardous locations. And we're used to seeing Class 1, Div 1, or Div 2 for flammable vapor atmospheres, but Class 2, Div 1, and Div 2 is for those dust atmospheres as well. So I think once you recognize the hazard is there, then make sure that your instruments and anything else you're going to use, fans, lights, anything else, is rated both Class 1 as well as Class 2, Div 1, Div 2, depending upon the situation. So understand the electrical classification of the equipment that you're using. We talked a little bit about wearing your full turnout gear. I think the other thing is the electrostatic dissipation from your shoes. If you were to come into a chemical plant, we'd probably make you wear ESD shoes or electrostatic dissipative shoes, because we want to take the static in your body, move it through your socks to your shoes, move it to the metal decking, move it to, ground eventually, so we don't have that discharge. And sometimes responders are wearing their boots, and their boots may have a lot of contaminants on it, and those contaminants may allow for more charge buildup on their boots and maybe not have that electrostatic dissipative part as well. So footwear is important, right? Our personal protective equipment, whereas firefighters or responders, doesn't always protect us in those situations, or could be the cause of not protecting us, maybe is a better way to say it. So, you got to make sure that your personal protective equipment, especially footwear, is the right one to use. Always wear your full gear too. The clothing you have underneath makes sense. A lot of firefighters wear cotton or FR for a reason, and those are great. But if you're wearing any type of synthetic or nylon shirts or anything like that, you could generate a decent charge underneath your gear, which could then be discharged. So the undergarments you're wearing, or your normal Class D regular, uniform that you're wearing, is important too, to make sure it's going to dissipate that static. So those are some of the things that we look for, other than the standard equipment.
Great. Thank you for that answer, Mike. One thing I like to utilize in all aspects, professional and personal as well, is a checklist. And I think if we're talking about what is something that we could prepare ahead of time for this process, is maybe a checklist here. What do you think that checklist should include?
Well, I think the checklist would, especially staying with the grounding and bonding situation, we talked about the ability of the crashed vehicle having capacitance of static electricity on the outside. One of the checklists should say, ground it and bond it as early as possible in the incident, because in grounding and bonding, just because you make a clamp connection doesn't mean that, okay, static's gone. You have to give a download time for that. So a checklist would be to give my grounding and bonding more priority, so that it's higher on the starting process, so that by the time my recovery team gets here, my response team, my recovery vessel or vehicle gets here, that crashed vehicle has been connected to a ground source and has had time to download or de-energize itself. So having the checklist to do that, but then also making sure that your checklist says, I'm going to have the grounding and bonding system set up so it's out of the normal work area. Eliminate trip hazards. Slips, trips, and falls are so important. And if we're intentionally putting down wires and cables on the ground, we need to make sure that we have those out of the way. And then just making sure that, okay, am I dealing with a flammable versus a flammable liquid or a combustible liquid? What is my temperature of the day? What's the temperature of the asphalt? What's the temperature of the steel rail that's in the sun? So you have to have some other ways to check down, ground it, test it, bond it, and then give it time to download or de-energize, and then look at how your environmental application is going to be. Do air monitoring to make sure that you have that taken care of. But checklists are going to keep you from being mundane. One of the worst things you can do is be confident. Okay.
Yep.
Confidence has really hurt a lot of people. Oh, I got this. No, get your checklist out.
Yep.
It keeps you from skipping a process or a procedure, and so many people, veterans of the industry, have been hurt by overconfidence in casual work areas.
Yep. I think a checklist is a great place to start. You can utilize my ground test, bond test as just a rough starting point. There's scene assessment, and determine material type and so on and so forth, so we can determine flow speeds. But sticking with a checklist and working through it every time, it's not going to hit everything, but it's going to hit your major pieces there. I think it's important to highlight relaxation times, which is what you were speaking on when you're referencing download. That can be hard, if not impossible, to predict on a scene. So general recommendation that I've always been told is 5 minutes. And I think that may be a little overly cautious, but it's a good place to start. You can find a lot more on relaxation times actually in a resource on the screen here, and that's the API, American Petroleum Institute's recommendations for static mitigation. But moving on to our next panel question, and we'll let Keith tackle this one first, and then we'll come back to you, Mike. What standards and best practice guidelines should responders and safety teams rely on when managing static hazard and creating that checklist too? And what resources do we have at our disposal, like NFPA or API recommendations, will translate into practical steps here? What are your thoughts on that, Keith? Where would you go if you had to direct somebody for a resource on creating that checklist? Where would you send them?
Yeah, sure. So if we're talking about hazmat, which we're talking about here, basically, go to NFPA 470. So 470 will address grounding and bonding as part of the new 470 that's out there. And then, of course, that is going to bring into play NFPA 77. And I would definitely go there. I mean, that's the standard on grounding and bonding. So a lot of stuff in there. I'd also jump to NFPA 70. I understand it's huge, but go to the part, again, I was talking about on equipment used in hazardous locations, because it'll really give you a good feel. Once you understand those classes and divisions, it really gives you a good feel for your equipment, your confined space blowers, your meters, et cetera, because they all have those ratings on there. So it's important to understand what that rating means. Sometimes we just use the word intrinsically safe and we think it applies to everything, and it really doesn't. I'm a big fan of the API RP on grounding and bonding in the oil and gas industry, as you mentioned. That's got a lot of real practical information in there. We use that a lot in the chemical industry as well. And then, some of the others, AEMC has some great stuff on your training resources webpage. There's a lot of cool videos, and there's a couple of taped webinars on there. So you got some really good information. I'd go there. NFPA's got some good information on grounding and bonding, and TRANSCAER's also got some stuff on grounding and bonding. But in terms of standards, 470, 77, 70, those are the big ones, and the API one.
So I put in the chat just a rehash of what you mentioned there. I did leave off 470. That's going to be kind of the principal document to start with. Check out NFPA Chapter 70. NFPA 70 Chapter 500 through 505 for those classifications. Right now, we're in the process of moving, kind of starting to move away from class and division. but it's still a very relevant subject to be aware of. You'll find more information on that in 505. And then 250 in NFPA 70, which is the National Electrical Code, it tends to get misused in this subject. So be sure to contrast the reasons for grounding and bonding in 250 as an electrical system versus NFPA 77, which is the recommended practice for static control, which is going to be a completely different subject, very similar concepts, but much different values found in 77. So, as a follow-up, Mike, what do you think departments and contractors can do to stay current on evolving standards and best practices? Any organizations or recommendations that those who are overseeing the training for these departments and teams should be aware of to stay relevant?
Well, I think that first we recognize that NFPA and API, there's a lot of thought process that go into both of those agencies and what they do. And as far as once you're trying to put this in practice, what are you going to do? There are so many conferences out there to attend. You can go to other online webinars. But whenever you look at a standard, this is what we're going to be gauged by. You want to make sure that you're hitting the right marks, and so checking at different conferences in your area, especially the Hazmat conferences, the International Association of Fire Chiefs, your own state and local fire department unions or instructor association groups. Those are all great places to get other ideas on how to train and how to meet the standards that are actually set by NFPA.
Great, and I think TRANSCAER can't mention them enough here in
Correct.
This instance. They have newsletter options and additional training that's completely free. I'll also mention too, Keith brought up our website at aemc.com. If you look for the term hazmat in the search bar, you'll find information on the kit as well as just some instructions. And even of those of you that do not have our kit, if you're looking for a base set of materials and instructions, a wonderful place to start there. So I'd recommend checking that out, and you can always reach out to us for more information there. So that wraps up our panel questions, but we will jump into some Q&A here in a second. But as we wrap up, remember that the static grounded bond test system from AEMC Instruments, it supplies everything you need to safely deploy and verify grounding and bonding in the field. It's complete, it's portable, it's compliant with the NFPA recommendations that we suggested earlier, and it's a ready-to-use solution for controlling static during hazardous transfer. Check out more on the kit with our authorized distributors, Mike being from one of those companies that is authorized to sell this kit, and more at aemc.com. So definitely check this out. It's a great kit, and it's purpose designed just for this here. So prior to the webinar, we asked for some questions from the audience here, and we got a ton of responses. So I picked a few that I thought were really important to cover as part of our question and answer here. And we've got just a few minutes here, so let's nail down a few of these. Someone actually from the Philippines, which I love that this is an international webinar, reached out to ask, like, they're in a high humidity country. Is it still necessary to do grounding and bonding here? Keith, I'll throw this over to you. I think this is something you'd be great at answering.
Yeah, I mean, short answer, yes, because you don't know in the field what the minimum ignition energy is for a chemical, what the contaminants are present, how the humidity really affects that. In a lab situation, you can analyze all that. In the field, you can't. So yes, even in high humidity, I'd be grounding and bonding. I'd recommend it.
Great. Yeah, I think it's important, again, to highlight that, yes, humidity does help to mitigate some of the intensity or that pressure that could be found in a static charge. But as Keith just highlighted, those are in controlled environments. And at a scene, there's a lot that is outside of our control that we cannot even predict. So taking the extra steps of grounding and bonding and relaxing the charge and ensuring that everything is is equal potential or equipotential is ideal for ensuring safety here. Brian from Louisville Fire in Kentucky asked, how long do we let things settle? He's talking about relaxation times, which we've discussed a little bit already, before transfer operations begin. And relaxation times or download times, like Mike called them, super complex subject. I have always, through the various trainings I've attended, heard 5 minutes as being the most conservative value that we can stick with. Keith, any input on that, since that's going to be an area of expertise for you from a chemical perspective? At one of these temporary transfer scenes, we're removing a material out of a damaged vessel. How long would you want to wait?
I mean, I think 5 minutes is a good rule of thumb. As Mike said, and I agree with Mike, get in there and ground it early and then bond it. And then by the time you're ready to go in and start to transfer, you've probably well exceeded that 5 minutes. So I don't know that, 5 minutes is the magic answer, but I think if you do it early, you're going to get a lot of good time in there. If you just hook it up and you want to transfer, then I'd back off and give it time to discharge.
Yeah.
I think in industry, or Mike could even talk more about transferring out of trucks, that usually has to do with the truck as well as the system, as well as the, specific commodity and the driver. So it can vary. Like in a plant, we have different guidance depending upon what pumps and what commodities we're moving.
Great.
That's correct. Volume of product means everything. If you have a 6,500 gallon tank and you have 4,500 gallons of product moving back and forth in the tank, it is generating its own static electricity in that flammable liquid. And so referring to a dielectric discharge rating, for me, Lang's handbook comes in handy. There's actually some very specific chemical specific relaxation times, whether it's a very fluid solvent like toluene or acetone versus a more dense product like diesel fuel or kerosene. Those are going to have different relaxation times and also different abilities to capacitate or to hold that that electrical charge. So you got to know your material too whenever you're coming to relaxation time.
Yep. Yeah. And that could be overly difficult. So I think having a longer time there, and to your point, performing the steps of grounding and bonding ahead of time before other scene operations occur allows that relaxation time to a charge there. And we're able to dissipate the majority of the charge that may be present. So Brian also wanted to know, and I'll take this one, if we could recommend an ohm meter that was user friendly. And that's what AEMC manufactures. We make electrical test instruments for varying different industries. The Model 6422 from AEMC Instruments is the meter that is found in the kit, but is also available for purchase separately too. So if you're looking for a good ohm meter that can do both measurements, both your resistance to ground, which is that fall of potential, very specialized test, requires a 3-pole instrument, and also a continuity measurement. Although this is not intrinsically safe, it can still be utilized for this purpose. The Model 6422 from AEMC Instruments is a great instrument to accomplish both of the tests that we've described here today here. And then one last question, or two last questions here. We'll tackle two more. I'll throw this over to our experts here because I don't know the answer to this one at all. What type of pump would you recommend for flammable liquids or corrosives? And Keith, we discussed this a little bit before the call, and I think you already highlighted this with the NFPA 70 piece there. But what would you recommend there? What would you look for in a pump for this type of transfer?
I mean, basically that it's rated for flammable transfer, right? And then it's rated for corrosives if it's a flammable and corrosive. Most of those pumps that are rated and designed for that, you want to use because of the inner materials, the compatibility, sparking, metal against metal, etc. But also they usually have convenient tabs to bond to, so you can bond the drum to the pump or bond whatever to the pump. So there are pneumatic pumps and things like that you can get into too, air operated, different types of pumps. But regular they're all rated for that chemical and as well as flammable compatibility.
Got
I don't
it.
know, Mike, you might have more on that.
Well, for me, a lot of times, being from the trucking industry, we just use a truck-mounted pump that was already set up for the specific chemical, whether it's a Roper pump, which is a rotary gear pump, where it literally chews up the product. But then you also have the Blackmer, which is an offset with uh, panels that slide in and out of a elliptical interior tank. So in my real responses that I did with chemical layman, we used a truck pump that came with the rescue truck. But then you also get into the double diaphragm pumps, the pneumatic double diaphragms. For those, you really need to make sure that you have interior gasket material that is compatible with your product, because some of these flammable liquids can gel or sticky an incompatible product, whether it's an EPDM rubber or Teflon, depending on what you're transferring. So you really have to check with the chemical manufacturer, the shipper, about what pumps are approved for this, because in the chemical industry, in the tank truck industry, we provided the shipper with the tank at their request, and they told us what kind of gaskets to use. They told us how to meet their specifications for guaranteeing product from the manufacturer to the end customer without changing it at all. And so making sure that your transfer pump is absolutely compatible with the material is important.
Great. Let's tackle one last question here before we bring this thing to a close here. Brian from Champaign Fire Department, Illinois asked, and this is a question right in my wheelhouse, so I'm glad you asked this, Brian. Is burying a ground rod horizontally as effective for emergency transfers as burying them vertically? And even more important, we could take out the aspect of doing this for emergency transfer. Well, that's why everybody's here, of course. It's just as effective in the electrical industry or other purposes that we would use an ground electrode for, or it can be. And can being probably the operative term here is that we have to be considerate of soil resistivity. The volume of the electrode, the size or surface area of it, is going to be key and critical here too. But resistivities of soils vary location to location dramatically in some cases, especially on the side of a roadway where other materials or chemicals may have been introduced, like ice melt, for instance. We could see that artificially lower the resistivity of the soil during certain seasons. So is it burying it horizontally more or less effective? That's a hard question to answer exactly, but generally speaking, yes, it should be as or similar effectiveness than if we were to drive vertically. Driving vertically does get us into more stable soil that is oftentimes going to retain its moisture content. But again, I have to highlight here that soil is incredibly variable based on its constituents, its moisture content, which is dictated by its constituents, electrolytic content, and so on and so forth. Timing of the year. The soils that are more closer to the top of the earth are going to be more dynamic in the fact that they dry out more. There's more capillary action in some different soils too, so they'll drain faster than like clays. But to generalize, yes, but if you're uncertain, testing is going to be your primary method for determining the quality of that connection in a resistance value known as ohms. And then the proper test there, again, is follow potential, utilizing a 3-pole instrument. So whether you go vertically, horizontally, at an angle, diagonal with a grounding rod, or even other materials, an electrode is just something that's conductive inserted or in direct contact with something that is non-conductive for the purposes of establishing an electrical circuit in that material. So we can utilize other things other than a grounding rod. A large chain, for instance, in a trench would work as a grounding rod. So really, it doesn't much matter where or how we make that connection to the earth as long as it's sufficient. And sufficient is hard to determine until we have a test instrument involved. So thanks for that question, Brian. I think it's a great question and helpful to understand, especially given the variability of various scenes. Some of you could be on the east or the west coast and dealing with a lot of rocky soil, and you can maybe drive a ground rod, especially like on the upper east coast. Maybe you get a ground rod into the ground 18 inches, maybe not even that before you're hitting granite. So knowing your options here and dealing with different various scene environments is critical to ensuring a speedy process when you remain or get onto a site here. So quickly, I really want to thank our panelists, Keith and Mike, for attending today's webinar. Your input and advice was critical to the success of this, and we really appreciate TRANSCAER's commitment to good training and providing great resources for those who are attending and other first responders out there. For those of you in the audience that are still with us, we'd love to hear from you. Was this format useful? Is there anything we could do to improve in the future? Please fill out a quick survey. We're giving away another instrument. This is a non-contact high voltage detector for working around dangerous or potentially dangerous voltages, determining if something is energized or if it is not. We're giving one of these away to somebody that completes a survey. We'll notify you in the coming weeks via email if you're the winner. Also, this link will be dropped or already has been dropped into the chat as well too if you're not able to scan QR code. So please complete that survey. We always want to improve our training and webinar processes. If you loved it, we'd love to hear it. If you didn't love something about it, please let us know as well too, so we can make it better. So again, thank you for joining us today for our Ground It Right, Reduce Static Disasters and Hazmat Transfer. Special thanks to our panelists again, sharing your expertise and experiences, and for all of you in the audience for your engagement and thoughtful questions. Got a ton of really good questions to start this thing off. As we heard today, static electricity is a hidden, but it's a really real hazard. Can't see it most of the time, but it's really there all the time, and it could be a hazard for us. The right grounding and bonding practices can make all the difference in keeping operations safe. We hope that you're leaving this session with some practical insights, some better understanding of the standards and resources available, and the strategies that you can bring back to your own teams. Checklist, right? We love a good checklist. If you want to revisit today's content or share it with a colleague, a recording of this webinar will be made available via YouTube, I believe. And more information about static control tools and training, check out the resources we provided, as well as checking out AEMC.com. On behalf of everyone here, I want to thank you again for your time and attention. Stay safe.